Before we move on with some more lab work, I did realize that I didn't give you the interfaces here for this topology, which didn't matter in the last video, but is definitely going to matter here as we go around and see what the effects of rapid spanning tree protocol are and see if it looks that much different from the actual spanning tree protocol output that we've gotten used to. One pop quiz question here for you though. Once STP or RSTP is done here, how many of these ports are going to be in blocking mode when we're done? Or in non-forwarding mode, however you want to put it. How many will be in non-forwarding mode? Okay, because it's a little different topology than we've been dealing with. Let's go ahead and get back to the lab, see exactly what's going on. And here we're running show spanning VLAN 1 on switch 1, and we see both ports in forwarding mode as we would expect because this bridge is the root, and with STP or RSTP you're going to have all designated ports here and they will both be in forwarding mode. Let's go over to switch 2 that is. I'll move that up, give me a second here, and move that up a bit. Both ports on switch 2 in forwarding mode as well. And we know why. One of the ports has to be the root port, and that's been selected as Fast Ethernet 1. It's in forwarding mode. And also switch 2 is on a shared segment, a separate shared segment that is, with switch 4. So we know that one of those switches is going to have the designated port on it for that segment, and apparently RSTP has decided it's going to be this switch, which is a designated port, the one leading to switch 4, and it's in forwarding mode. So let's go down to switch 3, and both ports here are in forwarding mode. One of them is going to be the root port, that's Fast Ethernet 3, it's in forwarding mode, and switch 3 also has a separate shared segment with switch 4, so one end of that is going to have the designated port and the other one, well, we'll see, but that one's going to be in forwarding mode as well. So far we've looked at 6 ports and they're all in forwarding mode, so we better have a port in blocking mode or 2 on switch 4. Now let me ask you, we got 2 ports here. Are none of them going to be in blocking mode? One of them or 2 of them? Only one good answer there, and that is one of them. Because switch 4 has to have a port in forwarding mode. That's going to be its root. So switch 4 has its Fast Ethernet 2 interface in forwarding mode, and that's its root port. And then finally, Fast Ethernet 4 is the one port we have in blocking mode on this entire network, and that is on the shared segment with switch 3. So whether it's STP or RSTP, this is what we're going to end up with. And again, 7 ports end up being in forwarding mode, only 1 in blocking, but that is enough to stop our switching loops. I think you've had enough of root bridges and designated ports and root ports for a while. I know that between this section and the STP section, there's a lot going on there with our root bridges, but it will definitely pay off for you on exam day and in the real world, I promise. This isn't just stuff you're learning for an exam, it's stuff you're learning for life. So we are going to move on to another topic coming up next. See you there.